guys, and welcome to this lesson on power. So power is a pretty short and easy topic, so I don't think this video is going to be that long. And if you don't already know me, my name is Naproud. I'm going to teach so that you guys can be ready for the exam, basically. If you have any questions, let me know down below, and yeah, let's get started. So power is equal to work done over time taken, or alternatively, energy transferred over time taken. This is because work done is equal to energy transferred. And it's the rate of doing work, and in simples, P is equal to W over T, where W is work done, T is time, etc. The unit for power is something called watts, W-A-T-T-S. Or it can also be joules per second, but it basically means the same thing. So mainly people just write watts. Okay, in terms of why power is a useful concept. Power is a useful concept because a lot of the time we care about how fast things will happen. Let's say you go and like build a house at school. Not at school, but like as a school activity, like, you know, one of those like building houses for the homeless activities. And then you have to lift some bricks or whatever. And so let's say you have a rate of being able to lift like 10 bricks per minute, which means you take about 6 minutes to lift one brick. I don't know, I assume that's like relatively realistic. But then you suddenly decide, like, this is not that tiring, you could lift more bricks. So you want to transfer more energy per second, or per minute, which would make it more tiring, and then you would need to use more power. So the way that you could do that is you could either like lift a lot more bricks at once, or you could lift more quickly. You know what I mean? So instead, you could lift like 4 bricks in one go instead of 1 brick at a time or something. And so you would be like taking a minute to lift like 40 bricks, or you could like try to lift 4 times as fast, and then you could also lift 40 bricks per minute, something like that. So that's the idea of power as opposed to energy. Energy is just like how many overall, not thinking about the time taken, but power is like thinking about how fast it is as well. Okay, hopefully that is okay. So another formula, which is not in IGCSE but does come up in A-Level, is power is equal to opposing force times terminal velocity, or P is equal to F times V. And this formula is used in the case where you have an object moving at a constant velocity and there's always an opposing force. So if you were watching my video before this, where I talked about an example where there was like a ball moving at a constant velocity of 8 meters per second, and then there was a force pushing it forwards of 20 newtons, and then the force pulling it backwards of 20 newtons, and so there was no overall resultant force. That would be an example of a place where you could use this formula. So in that case, P is equal to F times V. So I'm gonna draw it quickly. Let's say you have 20 newtons. Overall, it's still moving at a speed of 8 meters per second. So this would be its opposing force if it's moving in this direction. And so P would be equal to 20 times 8, and that would be 160 watts. So how is this value useful? This value is kind of like how much power is required to keep it moving at a constant velocity, because you always have to be pushing against the force which is preventing you from moving. So that's why you always have to exert power. It's like, let's say you want to drag a sled along. So you always have to be pulling with a force and to move at a constant velocity, that kind of idea. Okay, if we wanted to figure out how this power is equal to force times velocity relates to power is equal to work done over time, it's actually very easy, and below we have the derivation. So we can start with P is equal to W over T, right? And then W, work done, is equal to force times distance moved in the direction of the force. So that's this line here. Then after that, we can change the T from like being under the overall thing to just being under S only. And then that turns, because S over T is equal to velocity, S is like displacement, we get P is equal to F times V. So hopefully all of that is okay. If not, let me know if there's anything that you guys don't understand. So we're gonna do an example. This is, I think, from, honestly, I forgot what year it was from, but we're gonna do this question. Leonardo da Vinci proposed a flying machine that would work like a screw to lift the pilot into the air. The screw is rotated by the pilot. The machine and pilot together have a total mass of 120 kilograms. Which useful output power must the pilot provide to move vertically upwards at a constant speed of 2.5 meters per second? Ignoring the rather complicated flying machine, we're going to think about the concept of P is equal to F times V, which is the equation that we need to use in this question. And how do I know that this is the equation we have to use in this question? It's because this says power here, and so it has to really be one of the two equations, either P is equal to W over T or P is equal to F times V. And it doesn't really seem to say anything about work done and also time taken, so it's more likely to be the top one. So by process of elimination. But anyways, we also know actually what the force is. You might be thinking we don't know the force or any forces. But then in this case, what's happening, right, is as it's moving upwards at the speed of 2.5 meters per second, it's always going against opposing the downwards weight of this flying machine, which is 120 times gravity, 9.81. And so the force would be 120 g, which is the weight of this flying machine, and then the velocity would be 2.5. So we have P is equal to 120 times 9.81 times 2.5, and then we can calculate that to get the answer, which should be it's about 1,200 times 2.5. So it should be the last one here, 2,900. Mental maths, I think. Let me check that quickly. Yes, 2,943. Very useful to know mental maths. If you couldn't figure out how that was mentally, it's basically that 9.81 is almost 10. 1,000, so that would be 1,200, 120 times 10, 1,200, and then 2.5 is like 2-ish. So that would be about 2,400, but then it should be a bit more, so 2,900 works. Everything else is too small, the wrong order of 10. So we can always, like, in this case, it's actually pretty easy because this is just like, it's like tens, this is hundreds, and then this is the only one in the thousands, so it had to be D. Okay, that is it for this lesson on power. Let me know if you guys have any questions. Make sure to please ask. Subscribe for more videos. We will do the later videos in chapter 5 right after this. And give this video a like if it was useful. Go to www.naproudacademy.org in order to download our past paper packs and also questions by, what am I saying? Definitions list. Definitions list is very useful for your revision and for the exam. Okay, I see you guys. Thank you for watching. Bye.